I'll start record. And today I will demonstrate how you guys solve the level 5. And I previously released solving level 0 and level 1 as a video. So the purpose of the challenges are because we do not have a correct privilege to read the flag. So we need to trick the program level 5 because it has the runtime privilege for the group privilege of the week 1 level 5 solved or something. Yeah. So we need to drive this, figure out the input to drive this program to run the bin bash to inherit the group privilege at the runtime. Then finally we can read the flag. Yeah. And to do that, we need to do reverse engineering for the level 5. And before starting that, you can take a look at the README of the some of the hint for the file. Although I do not provide the source code, I provide a little bit of hint. And what it says is the pseudocode of the program is read the string from the user, get the length of the string, and the length must be matched to the predefined length, and then convert the input to an integer, then to a string, and apply XOR, and compare each byte to the password. So our input will be processed in these 4 steps, and then we need to figure out how to trigger get a shell function. And to do that, I recommend you guys use both the GDB to examine the runtime status and also some of the manual job for translating the assembly code into the C-like pseudocode. And after you translate the assembly to the C-like pseudocode, then you would have a better understanding for the program, and you can figure out some solutions to get the flag. And to start that, let's get the disassembly of the program. So to do that, you can run GDB, and first thing is you can disassemble the main function. And after watching the video for the tutorial level 0 and level 1, you guys have a better understanding of the translating the code a little bit. And then after you watch these 3 lines, you can easily think it's a printf call passing this address to EAX and EAX to the first argument. So it's calling printf with string. Yeah. So it says, let's start a more complex game. And then it calls the function password. And the password function is quite long. It has around the 624 bytes of the instructions. So let's copy and paste all the lines. Yeah, we got back the original size. Then, so I will create the disassemble.txt like this, and then I will run tmux to multiplex my terminal. So I set up some of the predefined configuration for the tmux. So you can also use the same setup. And then my control sequence is this backtick, the command, the key right next to the number 1 on the left top of the keyboard, right below the ESC. So if you press, no, sorry, backtick and %, then you can split the terminal like this. Yeah, and then I will open disassemble here, disassembly here. Let me move some of the zoom stuff down there because I cannot see some of the lines. Yeah, and then let me open GDB on the left side. Yeah. So now I'm ready for the starting some sort of our manual reverse engineering. Yeah. And then the first thing is we can easily identify the function prologue So push EBP, move ESP, EBP, yeah, push ESI, sub, ESP. These are like they relate to the function prologue. So you can refer to the the lecture slide about how the program uses a stack, and at the start, ESP will point to the end of the stack, and then it will move EBP to ESP, and then subtract the ESP with the some number to reserve some space on the stack for the local variable area. Yeah, and then it subtracted like a 0x264, which is around the 612 bytes, I believe. Yeah, in hexadecimal, but in decimal it'll be some of the number like that, and then that means it will reserve some big size for the the buffer or some of the huge local variables. Yeah, and then let's start to translating the assembly line by line. So XOR EAX EAX. So the instruction XOR is the applying exclusive OR to EAX, and then applying XOR to the same register means that the setting the EAX as a 0. Yeah. So for example, 1 XOR 1 is 0, and then any kind of value XORed with the same value will always be 0. So exclusive OR means that some of the different bits will be 1, or the same bits will be 0. So it will be always 0. So this is one of the trait that you can create the 0 with the one instruction. Yeah. And then the next instruction is the move 0x200, and then the focus on the dollar flag here. So the dollar flag means that this is an immediate value. So ECX will store 0x200. Yeah, this is not an address, an immediate value. And then the next is about the LEA, and then negative axis indexing over EBP. The negative indexing over EBP means that this is a local variable, and then we can regard this as some of the character. We don't know which is the type, but the EBP minus 204 is there. And then EDX will store the address of that local variable because the instruction is LEA. Yeah. And then next is about the function call. Yeah, and then we see lots of the accessing non-negative X indexing over ESP. So we can easily get these are for the a function call. Yeah. So let's analyze this function. So it will call memset. And the first argument is the ESP 0 indexing. So that's EDX. So it will be EBP minus 204 as an address. And then the second argument is the ESP 0x4 indexing. So 0. And then the third argument, ESP over 0x8 indexing, is to 0x200. Yeah. So it's just called a memset this for setting all the things as a 0 and then 0x200. And at this time, you can regard EBP minus 204 as a buffer size as a 0x200, which is 512 bytes. Yeah. So because it will set the 0 starting from this address for 512 bytes, set all the values as a 0. So you can regard this as EBP minus 204. Yeah. And this kind of the reasoning can be done because we know the semantic of the memset, because memset is setting the buffer contents with the the specific value. So, and then we can regard this as something like this code. Yeah. And if you have some of the questions on the some of these steps, please post on the chat. Yeah. And if there's a no question, then I will move forward. Yeah. Any question? Yeah. So 512 is because like this is a 0x200. This is a hexadecimal number, and then 100 is 256, and 0x200 is 512. Yeah. Yes, right. And then how about the EAX and ECX? So we will use that later, so that you just to reserve these kind of the assignment. And then because these are used and like in here, so I will interpret that too. So the question was about the EAX and then ECX, and then like these are also the local variable. So we know that maybe EAX and ECX, both of them are integer, and then EBP minus 224 is it gets the EAX value, so it gets a 0, and then EBP minus 228, this one, yeah, we'll get ECX, so 0x200. Yeah. So we interpret up to this line. Then let's move on. And here, so there is another variable, so EBP minus 210 will get the value 0. And then like for using the local variable, one of the important things is like whether that is a move or LEA. And then if that is LEA, you can regard that as a memory. So we can easily get this is an address, so that will be a buffer, something like that. And if we see the move instruction, then we can safely regard that as some of the local variable like this, not a buffer, but the integer variable or something like that. Yeah. So EBP minus a 210, that's also storing a 0 with the move. So we can safely regard that as a local integer variable as a 0. And then it compares 0x200 with that variable. So at here, whenever we meet the compare, we can either use if or while or for. Yeah. And then to determine which one should we use, we need to take a look at the jump instruction right next to the compare. So it will compare whether the value inside of this variable to 0x200, and then the jump instruction is a jump above or equal. So it tests something like if EBP minus 210 is above or equal to 0x200, something like that. Then, because this instruction is a jump, to continue to include like these instructions into the if clause, one of the trick you can use is like you can negate the condition. Then up to 235. So right before 235, because like if that is above or equal, it should go to this line, and else it should run these lines. So we can negate the condition, and then like these are the code that should be inside running inside this this if condition. Yeah. And then to determine if this is an if or while or for, what we need to take a look at is at the end of like right before the jump target, what's the instruction at the end of the if condition. Yeah. And then what it says is like it will jump back to password plus 69. So it has a comparison instruction, and then run something, and then it will jump back to the comparison instruction again. That actually means that this kind of the structure is composing a loop. So we can use either while or for. So for the other cases in like the in level 0 and level 1, we could not see like this kind of the jumping back to the original comparison instruction. But whenever you see jump back to the comparison instruction, you can safely assume this should be either a loop, so while, or for. Yeah. And to determine whether this is a while or for, that's actually doesn't matter, because like the while and for will be the similar thing, but just a syntactic sugar for the like the C language, you need to take a look at this like the sum of the few lines right just above the jumping back instruction. So at here, we are seeing that using up the EBP minus 210, which the value that will be compared at the comparison instruction. Yeah. And then the next instruction is that adding 1 to EAX, and then putting that EAX value back to EBP minus 210. And we can shorten these 3 lines as something like this. Semantically, these 3 lines are same as this one. Yeah. So in that case, we are seeing some of the structure like we set EBP minus 210 as 0, and then we compare that with the 0x200, and at the end, we increment it by 1. And this structure looks like something like, so let's regard, there's an integer I, and then that will be EBP minus 210. And then we can rewrite these lines as for, so not using this one, for integer I is 0. So that's come from this line. And then we compare that variable with the 200, but the jump above or equal. So it should be 0x200, but we will negate the condition to include these lines. And then at the end, there is a instruction for incrementing the variable by 1. Yeah. So we can write it as a for loop like this. Then it will jump back to the original place and then keep incrementing the loop variable EBP minus 210, and then looping again and again. Yeah. And after that, let's analyze what's the code is doing in the loop. So it will do the same thing. EAX will be 0. So XOR with the same value means that it's 0. And then ECX will be 1. Yeah. And then it will get EBP minus 208 as EDX, and then put the address of that. Yeah. So you can regard this as a sum to buffer or sum to memory. Yeah. And then put that value into EBP minus 20C. Like this. The difference is like this is LEA and this is move. So it will set the address value directly to the local variable. And then now EDX will store the same value. So this is actually doing the same thing. So this kind of thing happens because like these instructions are not that optimized because I didn't use like a compiler options to like optimize the thing. So one question is that just to clarify, the negative EBP values like are just using stack variables, right? Yes. So the negative access to the EBP, yeah, will always point to the local variable in the stack. So we only focus on the negative indexing over EBP. These are the local variables, and non-negative access over ESP. These are as like the passing their function arguments. Yeah. So EDX will store EBP minus 20C, which is the EBP minus 208, the address of that. Yeah. So there will be a little bit of aliasing, but if you keep track of that, then you can easily figure out which value was which one. And then next is about the function call, because we see that the non-negative indexing over ESP. Yeah. And then this is about read function call. And the first argument, 0 index over ESP is 0, value 0. And then the second argument, index 4 over ESP is EDX. So we put address of EBP 208 because EDX comes from here and there, right? And then the third argument, 0x8 indexing over ESP is 1. Yeah. So this read call reads 1 byte from standard input to the address pointed by EBP underscore 208. So it reads 1 byte to our local variable. That's it. Yeah. And then, so EBP minus 22C will get the EAX value, which is 0. And then EBP minus 230 will get, where is the ECX value, which is 1. Yeah. And then we will move forward. And then here's a little bit of like the, not that difficult. These are easy, but maybe you guys are not familiar with this kind of instructions, but I will explain that. Yeah. So the next is, it will put this value. So the address of the EBP minus 208, because EBP minus 20C stores EBP minus the address of the EBP minus 208. So I just put the address here, and then MOV SBL means that like it will get the 1 byte from the address. So move sign instruction byte from the long address. So that's the meaning of the the instruction. So it will move 1 byte from 4 byte address, and then 4 byte register, and then it will do sign extension. So you don't have to understand the full meaning of this instruction, and then you can regard this as you will read 1 byte because we read 1 byte from your input, and then it will store into 4 byte ECX register. And then if that is a negative value, and then it will extend with the sign extension. For example, if you put FA or something, then it will translate it as this kind of the actual negative value for the 4 byte one. But if you put 0x1 or something, then it will put the value like this. Yeah. So that's the meaning of the instruction. But you can safely regard this as putting 1 byte value from the memory. So, and what it does is ECX, but it will dereference 0 indexing from ECX. Yeah. So what it actually does is something like that. So it actually dereference address of the EBPs of the 208, and then this dereference and then taking address operations are actually the inverse operation. You can cancel each other. So what it does is the ECX will store the value that just read. Yeah. And then the next instruction is a comparison. So it will compare ECX with 0xa, and then the jump condition is a jump not equal. So to include, so although the jump condition is jump not equal, to include all these lines in the right next to the if condition, we can negate the condition, then, and then it jumps to the 189. And then we can write the else here to include the else condition about the doing all the others. And then the jump target of the if condition is ending at the 235, which is the end of the loop. So we can regard this as like how can we exit? So right now we are in the for loop, and how can we exit the for loop in the if condition? So that's actually break. Yeah. So we can interpret this instruction as a break in command in the C, and then the important thing is like analyzing some other lines, and this one is like the EAX will be put the EBP minus 234 as the value of the EAX, and then value of EAX is the return value of the read. Yeah. So to figure out the value of the EAX, you need to either find the assignment to the EAX or the closest function return, because return value of the function will be stored into the EAX. So EBP minus 234 will store the return value of the read. And then I believe like this is necessary to analyze, because like it will not use in the program, it will not affect to the program's execution. So it also exists there because this program is unoptimized. Yeah. And then we use EBP minus 210 as a loop variable I, right? So EAX will be I, and then the next instruction, move byte. So it will put 0. So we know that the right side will be something like this. And then take a look at the left side. And then if you take a look at the slide for there's a supplementary slide that I did not describe in the lecture video, but if you take a look at this kind of the memory, some of the special memory accessing. So this instruction accesses memory from EBP minus 204, and this multiplied by this. So EAX is I, and multiplied by 1. Yeah, and that's the actual memory accessing from this kind of the dereferencing. So this is not that difficult. It's similar to this kind of accessing. So EBP minus 204, and then you can actually dereferencing the variable with the second multiplied by the third one in this parenthesis. So multiplied by 1 can be omitted. So it's something like this. And we know that the EBP minus 204, we defined that as a buffer. So we can write it as buff I is 0. Yeah. And then let's move to the else condition. Then EAX will be EBP minus 20C. Yeah. And then that's actually EBP minus 208 address of that. And then it will move it will dereference EAX to CL register. Yeah. And CL is a lower 8-byte of the ECX register, so you can regard this as a 8-bit 1-byte register. Yeah. And then we know that the EBP minus 210 is a variable I, so EAX will store I, and then we also have like this kind of the triplet accessing. So this is EBP minus 204, which is a buffer, and EAX multiplied by 1. Then that's I multiplied by 1, and this one. Then we will put CL here. So put the character that we just read from read function to the buffer. Yeah. And after that, it will jump to the 215. So this is another the unnecessary instruction because it will continue to execute like this. Yeah. And then these are for the maintaining the for loop. So now the code is a little bit dirty, but what we have analyzed, so let's summarize that. So we have seen that there is a memset buffer 0, 0x200, and then we have a for loop. Loop, and then there's an if condition that no, there was a read function 0 and EBP minus 208 is an address 1. And then because this is a 1-byte, we can safely regard there's a 1-byte character EBP minus 208, and then we can read the 1-byte character and compare that with 0xa. A as a character is actually a new line. Yeah, if you refer to the ASCII code, then you can easily know that the 0xa will be the new line. And then if that is true, and what it does is this one, buff I is 0 and break here. And then else, what it does is buff I is EBP minus 208, and then it increase the loop variable and continue. So it's something like this, and you can safely change EBP minus 208 as some of the character variable C. Then it can be predefined like this. Sorry. And what this logic does. So it reads character by character and stops when it matches to new line. And if it doesn't meet the new line, it will keep adding the character to the buffer. So it's something similar to this. Yeah. So it just get the input from the user, and then just until the new line comes in. So it gets one line from the user. Yeah. So it takes 30 minutes to the analyzing this kind of the simple function. But if you are getting familiar with this kind of the process, then the speed of this kind of analysis could be faster. So please don't get frustrated when you try to manual reverse engineering like that. And then for the next one, I will speed up a little bit because you guys now get familiar with the detection of the loop, and then a detection of this kind of the reading of this kind of the triplet for the memory access. So let's take a look at these 3 lines. So this is also move, compare, and jump above and equal. And if we see the jump, we need to check that this line, and then right before this line, we have a jump condition, and it jumps back to the comparison. So this is another for loop. So what we will do is we will regard another int I, and then that as EBP minus 218, because this is the local variable. And then we can write a for loop, I equal 0, because it's set as a 0. And then the condition is above and equal, and negate the condition to include these lines. And then I should be less than. This is the comparison instruction. So like this. And then right before this jump back instruction, we can see the adding 1 to EBP minus 218. Yeah. So these are the part for the jump back and the increment. So we can easily get it as a I++. Then these things are what we are doing inside the loop. Yeah. And then we move EBP minus 218 to EAX. And then EAX is EBP minus 218. That's the I. And then this one. So EAX will store EBP minus 204. This is a buffer. And then EAX is I multiplied by 1. So we will just read the character at position I to EAX. And then we will compare EAX to 0. But the reason why I use if condition is that there's no jump back, because this is JNE to 301. And then after this one, it will jump forward to 306 or to 326. So it's not jumping back to the original comparison instruction. So this is not a loop. So I can safely use if condition, and the jump not equal, and I negated that to equality to include these two lines. Yeah. Then if EAX is 0, then so I can change it as a buff I is 0, because EAX will refer to the buff I. Then EBP minus 218 will be EAX will store I, and then put I to EBP minus 214. Yeah. And then, so this is the end of the jump instruction. So if it hits this line, then it will jump to the 326, and then this line actually will never be executed. So this is also happening because like this code is unoptimized, so I can remove that. So if it hits, it will exit the loop because the loop ends at here. So breaking the loop in the if condition, we can write it as a break. Yeah. So up to this point, we can rewrite this code as for I int I equals 0, I equal I less than 0x200, I plus plus, and then if buff I equals 0, then EBP minus 214 will be I and break. Yeah. And then let's combine all the code above here to there. So I will accumulate code to give a better understanding for you guys. So from here, we set the buffer as all 0. And then for here, it's one line from the buffer. And then if we met the new line, it will truncate the new line character as a 0. And then from this loop, we will go over from 0 to 200. And then if it matches a 0 character, then it will put the index to this variable and break. And can you guess what it does? So it will actually reading over the string, and then if it matches 0, then it will record that position to EBP minus 214. So it will store the length of the string to this variable. So we can regard EBP minus 214 will store the length of the string that you give the input to the program. So you can regard this as a string length of the buffer. Yeah. And then next is comparison instruction and the jump. And to determine if it is a if, for, or while, so we need to check that the 382, but we don't have any kind of the jump back instruction. So we can safely assume this is an if condition. And then EBP minus 214 is a length variable right now. And then the condition is jump equal. There is one question. So yeah, find the length, right? So string is ending with the 0 in the C program. And then what it does is that it goes over to the buffer from index 0 to 0x200. And then if the current index contains the end of the string character, then it will store the current index, which is the length of the string, to the variable. That's why that's why I assume that this function is just to do the string length like stuff for finding the length of the string. Yeah, and then the variable stores a length, and then it'll be compared with the number 7, and then the condition is a jump equal. So to include the following instructions, so I negate the condition, and then it does printf this address, and then to get it, so it says wrong string length. So it seems like we are getting the correct reverse engineering. Yeah, and then it does something, but we will ignore all these because there's an exit function. So it calls exit, and then first argument is ffffff. That's actually -1 in the 2's complement format. So the length of the string that we need to put match it to the length step 7. Otherwise, it will just exit. Yeah. So that's the code about the length checking. Then let's move forward. Yeah. The next function call is ATOI. And then this one is easy. So LEA EBP minus 204, put that into the first argument. And then we know that the EBP minus 204, we use that as a buffer here, right? So you guys need to follow all the like which variable goes to the which semantic variable that we set. Yeah. So at here, you need to do ATOI buffer, and then return value of this one will be stored to EAX. So you need to follow that one. Then next one is the function call of sprintf. Yeah. And then before that, let's figure out how EAX, this is the return value of the ATOI, will be stored. So it will use EBP minus 21C as EAX. And then we can change this as a result of ATOI as this one. And I assume like you guys all know that what ATOI means. So it's something like if you type 1, 2, 3, 4 as a character, then this function will change this character 4 bytes as a integer 1, 2, 3, 4. Yeah. So it's just the a2i. So that's why. Yeah. And then we will figure out the arguments for the functions. So now ECX will store 0x14. And then EDX will store LEA. There's a no dollar flag, so just this address. Yeah. And then ESI stores the buffer address. Yeah. And then EAX will stores a result of the ATY. We will put that into the local variable here. Yeah. And then this is another silly instructions to do the same thing again. So we can ignore this. And then put ESI to the first argument. So we can write smprintf. So the first argument is ESI, which is buffer. So we will reuse the buffer. And then the second argument is 0x14. And then the third argument is EDX. And where's EDX? So the string. And then let's check what it has. So %u. Yeah. And then fourth argument is EAX. And then EAX is result of ATY. Yeah. This is the function call. And then it stores ECX to 0x EBP minus 240. And then ECX value is coming from 0x14. Yeah. So this function calls snprintf. So S means that it will run printf and then store the result to this buffer string. And then N means that the maximum length. So it will print up to 16 plus 4, 20 bytes. And then it will use format string %u. And I'm not sure you guys know about like what %u means. So it will print out the unsigned decimal number. Yeah. So it will regard the result of the ATY as a unsigned integer. Yeah. So it will print out the result of ATY into unsigned number. So you can regard that this is actually the inverse of the ATY. So for example, if you put the string 1, 2, 3, 4 here, then EAX will be 1, 2, 3, 4. And then if you pass 1, 2, 3, 4 here, then buffer will be 1, 2, 3, 4 again. Yeah, something like that. Yeah. So you may think that this is a silly operation, but this is actually different because the result of the ATY will be signed integer, but it will regard that as an unsigned integer. So that's the one of the secret that you can solve the problem. I will explain that more after finishing the analyzing the program. Yeah. And then we are going towards the last part of the analysis. We only have like a few more lines to analyze. Then let's do that. So there's another jump instruction. And then let's go to the 591. Yeah, this is the end of the if condition because jump target is there. And then we see jump back instruction to the comparison. So this kind of structure composes a loop. And then we can regard loop variable as a ABP minus 220 because that's set as a 0 and compared as a 0xa. So what we can do is for int I equals 0, I must be. So the condition is greater or equal. So I just negate the condition. And then it should be smaller than 0xa. And then right before jump back, we are seeing that adding 1 to the same variable. So we can write it as I++, right? Yeah. And then we can wrap it like this. And the EAX will store EBP minus 220, that's a variable I. Yeah. And then this one, EBP minus 204, that's buffer. And then EAXI means EAX1 means accessing I. And then this instruction is the getting the 1 byte from the buffer. Yeah. And then it will apply XOR1 to the EAX, and then semantically we can rewrite this like this. Yeah. And then this is another unoptimized instruction. So the ECX will store the variable I. Yeah. And then, so this one is looks weird. So you can regard empty first, this kind of the differencing as just differencing this address. So this is a global variable. So this is why like it directly uses the some address, not the based on the like the referring to the EBP. Because I told you that the positive negative index over EBP refers to the local variable, but some of the accessing directly using the address would be like the accessing the global variable. So I will just put it as a global 3C because it could be a little long. Yeah. And then ECX is I, and then 1 is the multiplier. So we will access it like that, and then put that into ECX. So it's getting the 1 byte from the global variable. Yeah. And then it will compare and jump. And then if we go to the 566, so it will jump forward because the number is bigger than this one. So we can safely use if condition here. Yeah. And then jump equal finishes the loop. So buff I XOR 1 is the EAX. And then we compare EAX with the ECX is not equal to global variable. Then this is if condition will be executed. And then this printf is easy one. What is this string contains? Wrong password, access denied. So it means that we need to match some of the condition. And then this is also exit -1. And then afterwards, it will finish the loop. So it will move forward to here. Yeah. And then it will printf this string. So if we get the password, so it will print out this message and then run, get a shell. Yeah. So this is the end of the analysis. And then let me combine all the code to have a clear understanding of what we are doing. Let me copy and paste all the thing, and then I will delete some of the assembly lines. Like this. And then we don't need all these lines. Then what we need is this one. Yeah. And then what we need is this if condition. Yeah. then I can indent this. So the code will be something like this. So it will do memset buffer 0, and then it will get one line from the user, and then it will get the length of the string, and then the length of the string must be the 7. Yeah, otherwise it will exit, and then it will do ATY 50, and then get the EAX, and then print that as a string for the unsigned number. Yeah, and then for the 10 characters, it will compare the result of the smprintf XOR by 1 to the global variable here. Yeah, and then if any of the character gets wrong, then it will say wrong password, access denied. Otherwise, if we get the all 10 characters got correct, then it says, great, you got my password. Yeah. And then some of you might think that we can only type 7 characters, but we need to compare our input. So ATY and smprintf could be something inverse operation. Yeah. And then we need to compare that to 10 characters. And then each of the bytes XOR by 1, yeah, to be same with this global variable. And let's check what's in that global variable. So that global variable was here. And then the value is this one. And then to get what is the XOR value of this one. Yeah. Then so for C or DC, for C in S, and you can get all the ASCII number, and then you can XOR by 1, because XOR is a commutative operation. So we can apply that to the secret password, then we will get what kind of value we should generate into the buffer. So XOR, apply an XOR here or XOR to here will be the same. So that's why I just get the XOR value here. And if we join the string, then the value we need to generate in the buffer is 4294967291. There was one question. Yeah. Why shouldn't we just decode the function getShell to get the answer message? So what we need to do is we need to execute getShell. The only way you can execute getShell is the not hitting the exit -1. So if your input not size 7, then you will get exit -1. So for example, let me try it. 4 character, long string length. 7 character, so string length is correct, but the password is wrong. Yeah. So we need to meet all these conditions to execute getShell. That's why we need to analyze all this kind of right, that's right. getShell does not give you the flag, so it will give you the shell, and then you need to run cat flag afterwards. Yeah, that's why. Yeah. So if you can figure out the flag in the binary, then you don't need to do it. But the purpose of this challenge is that you need to steal the privilege from the binary program. Yeah. Yeah, that's why I didn't analyze getShell function at all from the level 0, level 1, and even for this level. Yeah. Yeah. And then the last challenge is that we need to figure out what kind of value will get us to get this value, in the this program. So the problem is that we can only type 7 characters, but the value we need to generate is like this value. But the hint says, so it says about 2's complement. And then if you get to the 2's complement or something, then you can realize that it's about the negative numbers or a signed number representing the signed numbers in there. So let's try a simple thing. So for example, I will write a C program, and then I will just use, then print out with %u and -1. It prints out for 4294967295. It's somewhat similar to this number. Then try -2. One decrease. Then if we decrease a little more, then it could hit this number, right? What about this? Yeah. So if we put -5, then it will generate this number. Yeah. Then can you get like this? No way. We need to fill the string length as 7. And how can you do that? We can trick this ATY function, and then ATY function works well with the lots of zeros in front of the value. So if we do something like this, then these are 7 byte -5, and then that will be translated as this number in the 2's complement format, unsigned integer. Yeah, so we can get the privileged cell. So now you can get the group ID of this one. Yeah, and this is how you can solve the level 5 challenge. And then I will not do the cat flag because I don't want to leak the flag in the video. So please do that by yourself to get the flag. And I will take questions from you guys for the this tutorial. Is there any question? No, it will not stop. This 0 is number 0. Yeah, number 0 is like actually 0x30, not the actual value 0. So value 0 at here is null. Yes, that's right. This character 0 is ASCII code 0x30. Yeah. So the code means that the code says that like the number XOR by 1, should be the same as this password, and then we got the password as a 53, this kind of the number, and then XOR is a simple decoding function. So if you apply XOR by 1 to this one, so what I did is like in Python, I got the string s, and then for each character, I got the character code, and then apply XOR by 1, and then get back the character. This is how we can decode which value at here will generate the this password when we XOR by 1. Yes. So it's something like x XOR 1 XOR 1 will be the x. So I just apply the XOR1 on the password side to get the actual value that we should get. Any other questions? So from the code, we see that this address, and then in GDB, we can get the password string. Yes. And then this tutorial is also available on our course website. So for example, I will share the screen. Wait a moment. So if you go to this tutorial 3, that text file, then you can see all the detailed steps about like the how we can analyze the thing. So I will post the video of like the current tutorial later when it's available on the cloud. So you guys can access that. And also in the meantime, you guys can play with this text file. And after I got the video, then I will post the video link at here. All right, it's already over the time. Sorry about that. The tutorial gets a little longer. And hope you guys get the good idea about like how to solve the remaining challenges. And we will go over a little bit more tutorials in the next Tuesday. So please have fun with the challenges. And yeah, please do not struggle too much. For example, like stuck with a challenge for 5 hours, that's not good. So please ask some of the questions on the Discord, and the other students or like TAs or myself will help you guys. And thank you for your attention for the tutorial, and please have fun. Yeah, and let's conclude today's tutorial here. Yeah, thank you.